Hello everyone, how are you? I hope you are fine. Today we will solve a new problem. It's of medium level. Generate parentheses. Problem number 22. And we are given an integer, a number n, which represent a pair of parentheses. Like 1 is like open and close. So it's a pair. 1, it represents both open and close. So 1 is open and 1 is close. If 2, that means we have 2 open and we have 2 close. If 3 and so on. But what's required from us, given the n, is to generate all the valid combination of well-formed parentheses. So in this example, 3 will give us 5 valid possibilities, like could be at the beginning 3 open then 3 close, or like this one open close open close open close, or like this one open close open open close close. As you know, the parentheses, we cannot start with the close, we should start with open, and every open should have its close round bracket. So I think you know what's the valid formation of parentheses, how it should look like. So I will jump in the algorithm how to solve it. So I wrote a backtrack function here, GP, I will call GPB. So generate parentheses backtrack, and it will accept these parameters: string, the current string, and how many opened and how many closed, to judge the algorithm. Of course, it will start with empty string 0 0, and every time we insert open or close, we will put it here. Okay. So of course, when we start, we have no choice but to open a parenthesis. We cannot start from close, and the number of close parentheses at any given index or point of our string cannot be more than the open. The open can be more than closed, like for example here there's 3 open and 0 closed till this point, but here there's 2 open 1 closed, and here like there is 3 open 1 closed. The open can be more than closed, but the close cannot be more than open, because when we cannot close unless we open something. So the start, it's very clear, we have no choice but to start with open. So we have this one. So now it's open 1 and closed is 0. We have no other choice. And while we have open, we have we have two choices here. We can either we append another open like this one, or we append the close like this one. And I draw this algorithm, all of it. So I will not go through each step one by one, but I will explain to you the conclusion of this algorithm. We can find this conclusion. At the end, we return string. We append the string to the result. We have an empty array of result. And when we reach to the down, to the bottom, to the final step, we append the result. We append the string to our result array. But how do we know we reached to the result? We can use many conditions, like the length of string should be 2 times the n, like because 3 open and 3 close, so 2 times 3 is 6. Or we can say there's 3 open and 3 close. But the simplest condition we can do is simply say if the close is equal to n, which is 3 in this example, then we reach to the bottom. And of course, if the close is 3, the open cannot be 2 or 1. As we mentioned, the open cannot be less than close, so it could be either equal to close or more. And because n is 3, so the open also cannot be more than 3, because this is the maximum number. So simply by saying the close is equal to n, we reach to the final step and we can append the result to the array. So for this, we found the result and we append it to the array, the last line. Okay, if you notice here, there's some line we have two choices, while other we have only one choice, we have no other choice. So let's break it down. We have cases we have two choices, we can call the function twice with every case, with every choice. And there sometimes we have one choice, and even the one choice sometimes is open and sometimes is closed. So let's explain the theory. When we are forced only to close, we cannot open. Of course, when we open all parentheses, if n is 3 in this example, n is 3, and we already have 3 opened, then we have no other choice but to close. Of course, if n is 3 and it's all open, we have no other choice but to close. So like example here, it become here 3, with this open it become 3, so we have no choice but to close, So as you see here, after this we have to close, we have no other choice. So every time n is 3, the next step is close. And you see here, the next step is close, not the current step. The next step is close. The next step is close. Same here, the next step is close. Where we have here the next step, and the next step is close. We have no other choice because we already opened the maximum possibility of opening brackets. So when the opened is already at max 3, we have no choice but to close. So we will put condition in our function. If opened equal to n, then we call the function with the close parenthesis, and of course we update the number. Okay, so but we have other choice. For example, where like example here, okay, here we have one choice. So when the opened equal closed, like this line, let me pick another color, let me pick this color, like this one, or like this one, or like this one. When open and close is are equal, then we cannot close, because the close cannot be more than open. We cannot close a parenthesis unless we open it first. So we have one open, one close, one cancel each other. So the next step we are forced to open. So you see here, we have to open. You see here, we have to open. And you see here, we have to open. What's left now? What's left is the two choices. When this happened, like this one, like this one, and like this one, and this one, and I think this is all. Yeah. So when it happened, when do we have two choices? It happened when the open is bigger than the close, and open does not equal n. Okay? Because if open equal n, so we cannot open anymore, we have to close. We have only one choice, is to close. But when open bigger than close, like this one, one open and 0 is closed, we have two choices. We can open more, or we can close the current open one. Here, as you see, we can open another one, or we close the current open one. And the same is here. We can open a new one or close the current open one. So we have three conditions. Okay, and let's go now to the Jupyter Lab and write the code, and I will explain more there. So let's define the backtrack function. Let's call it GPB for string and opened and closed. So if closed equal n, that means we are at the end. I need to first initialize an empty array. So result equal empty array, that will store the result. So if close equal n, that's it. We reach to the end. We do result dot append the str. And we can call return, even it's not necessary in this code, but I call return. Else if opened equal to n, like example opened equal 3, so that means we have no choice but to close. So we will update the string, we will add to it close parenthesis, we have no choice but to close, and open will be the same because now closed it will be increased by 1 because we add closed parenthesis. Else if opened equal closed, we have no choice but to open in this case. So we will call str plus open, and open will be +1 and close will stay the same. Okay, else, which mean in this case the else what's left is open bigger than closed, but open does not equal n because we consider the possibility here. So what's left is open bigger than closed, but open does not equal n. We have two choices here. One, we can add an open parenthesis, so we call this function opened +1 and close stay the same, and we also call close parenthesis, okay, open stay the same, but the close will be increased by 1, and that's it. This is the whole code. So we call the backtrack, we can call it by the way like this, and also we can call it like we start with open bracket and we say opened already 1 because we know the first choice we have to open a parenthesis, but doesn't matter, we can start from very initial state like empty string and 0 0, and we do return result. So let's test it here. Seems working fine. Let's copy this code and go to the Leetcode website to test it there. So I pasted the code here. Let's submit and see the result, if it's successful or not. Yes, successful. Time complexity, I don't like it. Let me submit again. Yeah, now it's better, 100%. Yeah, when you submit it may be different a little bit. Okay, it's working fine. Thank you very much for watching. Please don't forget to leave a comment, and I'll see you in the next video. Bye bye.